Hello everyone, welcome to my channel Shah Classes and Evershine Coaching Center. I am Shah sir here. My dear students, today I am going to discuss subject mathematics and the topic non-linear relationships, functions and their graphs. I just want to tell you the topics what we are going to cover in this session. Okay, we are going to cover about how to explore the parabola. We are going to explore the complete parabola and its curves, and also we are going to discuss about the axis of symmetry, and we are just going to discuss about the x-intercept, y-intercept, and how to identify the axis of symmetry, x-intercept, y-intercept in the given graph, and also we are discussing the turning point, and the last topic what we are discussing in this session is simple transformations of the graph of y is equals to x square. So my dear students, these are the topics what we are going to discuss in this session. We are going to explore the parabola and then about axis of symmetry, x-intercept, y-intercept, turning point, and simple transformations of the graph of y is equals to x square. I hope you all are enjoying this session. This one video consists of many topics. Okay, so these are the very important topics for your examination point of view and also for the academic curriculum. Let's start. Now, still if you have not subscribed to my YouTube channel Shah Classes, kindly do subscribe and click the bell icon and select all so that you can find the instant notifications and updates from our end time to time. Let's begin. Now, observe here. Here, what is parabola? What exactly the meaning of parabola? Observe here. It's very simple. Now we are going to explore the parabola. Let me to give the headline. We are exploring parabola now. Okay, good. Now, as you can see here, it is one of the most simplest. It is one of the most simplest and important non-linear graph. Okay, you should know this. This is very important. What is parabola? It is one of the most simplest and important non-linear graph. If you want, you can write is the parabola. Is the parabola. Okay, done. Now, here, as you can see, the standard form of the parabolic curve or parabola is y is equals to x square. This is very important. You should not neglect and forget this point. Okay, done. So what is the standard form of parabola? The standard form of the parabola is y is equals to x square. It is also called as, it is the basic rule. It is the basic rule. Done? Good. Now, one more important key point, that is these quadratic rules such as y is equals to x minus 1 whole square, comma, y is equals to 2x square minus x minus 3, and y is equals to x plus 4 whole square minus 7. Also give graphs that are parabolas and are transformations and transformations of the graph of y is equals to x square. So here we have just explored the parabola. It is one of the most simplest and important nonlinear graph, that is the parabola. The standard form of the parabola is y is equals to x square, and it is called the basic rule. Quadratic rules such as y equals x minus 1 whole square, y equals 2x square minus x minus 3, and y is equals to x plus 4 whole square minus 7 also give graphs that are parabolas and are transformation of the graphs of y is equals to x square. Now let me do one small activity to understand these basic concepts, and this is very important for your examination point of view. Let me have a glance of that. Okay, the question is, please copy down. Compare the graph of y is equals to x square and complete this table and plot the graph of each equation on the same set of axes. Okay, so you have to compare the graph of y equals x square and complete this table and plot the graph of each equation on the same set of axes. Let me take down the values of x, minus 3, minus 2, minus 1, 0, 1, 2 and then 3. Let me take first y1, that is x square, y2 is minus x square, y3 is x minus 2 whole square, then y4 is x square minus 3. Okay, let me draw the table for this, so it will be easy for you to understand. Done? Good. Yeah, so this is my actual table which I have drawn here. Done. Now as you can see here, the problem is, if we have to find the value of y1, if the value of x is minus 3, okay, as per this equation, what will be the value of y? If value of x is minus 2, then what is the value of y? If value of x is minus 1, what is the value of y1? Same way, similarly 0, 1, 2, 3. I'll just show you some two equations. The rest of the things you can try. Okay. So first let me take the equation y1 is equals to x square. Okay. So what is the value of x here? Can you see here? The value of x is minus 3. So here in place of x, if I am going to substitute minus 3 whole square, minus 3 whole square is minus into minus, negative into negative, that is positive, minus into minus is plus, 3 3s are 9. So the value of y1 is plus 9. Similarly, if the value of x is minus 2, then what happens? It becomes plus 4. If value of x is minus 1, then what happens? It becomes plus 1. If it is 0, then it is 0 itself. Similarly, if it is plus 1, then it is 1, plus 2, then it will becomes 4, as per the equation y1 equals x square. If it is plus 3, then it becomes 9. Is this clear? I hope you have got this step. Similarly, we can try for y2. So what is the value of y2? That is minus x square. Shall we substitute? In minus, the value of x is minus 3. In bracket we write minus 3. That is equals to minus 3 whole square is 9. Then the final answer is minus 9. Then minus value of x is minus 2 whole square minus minus 2 whole square is plus 4. So the final answer is minus 4. Similarly, minus of minus 1 whole square. So it becomes minus 1. Then minus 0 square, it becomes 0. Then minus 1 square, it becomes minus 1. Then minus 2 square, then it becomes minus 4. Similarly, minus 3 square, it becomes minus 9. Okay, negative 9. I hope you are understanding how to solve this. Just put the value of x here, minus 3, minus 2, minus 1, 0, 1, 2, 3. Same way, minus, again in place of x, substitute minus 3. Find what is the answer for this. Similarly, you can try even for this, x minus 2 whole square, x is minus 3, minus 3 minus 2 is minus 5, minus 5 whole square is plus 25. Like that you can try for the next below two equations. So now we have found the value of y1, y2 and y3. Okay, here the actual question is compare the graph of y equals x square. Now we have to compare these equations with y equals x square and complete this table. We have already done that, and plot the graph of the equation. Now we have to plot the graph for this. Let me see how to plot the graph. Okay, and it is very easy and very simple, no need to worry. So I am just showing you the rough drawing of this. Let me draw a y-axis and then let me draw an x-axis. Done? Good. And this is the coordinate 0, 0. Okay, this is our x-axis and this is x dash. Similarly, this is my y-axis and this is my y dash. Let me take the positives, positive 1, positive 2, positive 3 and positive 4. Okay, I am just showing you the basic steps. Then negative 1, negative 2, negative 3, negative 4, it goes on. Similarly, positive 1, positive 2, positive 3, let me take positive 4, negative 1, negative 2, negative 3, negative 4, it goes on. Now, as you can see here, what is the x coordinate? The x coordinate is minus 3. Am I right? What is the x coordinate? It is minus 3. So, where is minus 3? It's here. Then what is y coordinate? Is plus 9. Okay. So, how can you find? But here we have a small graph, right? Yes. But you can start from the least number. In this case, what you can do? You can start from the least number. I'm just showing you here. Okay. As you can see, let me to minimize the screen. So, now you will be getting the exact picture now. Okay. Now, let's see how to solve this. First, you take the coordinate 0. 0, 0. This is my coordinate 0, 0. Then you can take positive 1. If it is positive 1, plus 1 and y is also plus 1. So, this is my coordinate 1, 1. Take 2. This is 2. And what is y? Y is 4. y1 is 4. 2, 4. It's here. That is 2, 4. Is this clear? Good. And still you will get 3, 4, 5. You no need to try for these all numbers. At least minimum 2 points if you get, it is sufficient. 3 points. If you are getting 3 points, okay, then it is more than sufficient. As you can see, this is my one coordinate, second coordinate and third coordinate. Enough. You no need to find, you no need to locate all the points. Done. Now you come to the negative side. X is minus 1, y is plus 1. So this is my minus 1 plus 1. Then this is my minus 2 and this is my plus 4. Let me take, this is minus 2 and plus 4. Enough. Now what you have to do is very simple. Just turn the tilt the page, then just freehand drawing. It should be a freehand drawing. You should not use the scale. Okay, just join this coordinate with this coordinate. Then slightly you have to bend the curve. Okay, you will get the curve like this, and then just move away. Just join this coordinate with this coordinate. So this is my graph. So this is the graph of y is equals to x square, or y1 is equals to x square. I hope you have understood. But actual parabola graph you will get in the shape of a U shape. Okay, so still, yeah, you will get in the shape of U shape. You will get a curve in this way. Okay, this is a parabolic curve. Is this clear? So we have plot all the points on this x and y plane. So I hope you all have understood the basics how to plot the graph. Done. Similarly, you can try with y2, you can try with y3, you can try with y4 also. You can draw different plots and you can draw the graph. If not in the same curve, in the same graph, you can just draw the curves so that you will be finding the deflections, how exactly this varies from each other. Now, so we have done this. I hope you have understood this basics. Am right? Good. Now, okay. Now what we do? Very simple. Now we are finding the next step. Okay. Now we are going to study about the axis of symmetry, x-intercept, y-intercept and the turning point, etc. Before going to that, let me understand with simple graph. Okay, I am just showing you a graph which illustrates all the different things what we are going to study. Okay, now let me consider the equation. Okay, that is y is equals to ax square plus bx plus c. So what is y is equals to ax square plus bx plus c? Okay, so this is the standard form of quadratic equation. Okay, the standard form of quadratic equation. Let me to highlight here. We know that the standard form of quadratic equation is ax square plus bx plus c is equals to 0, where a, b and c are coefficients, or sometimes we call it as constants. Okay, and then here x is the variable. So what does it mean? It means that a, b and c values we know very well. Okay, the values which are known, those are called as coefficients. The value which we doesn't know, the unknown term, is called as variable. Let me take an example. 2x square minus 3x plus 5 is equals to 0, in which the value of a is plus 2, the value of b is negative 3 and the value of c is plus 5. These all are the known values, but here x is the variable. And remember, the highest degree or power or exponent of the quadratic equation is 2. So the highest degree of the quadratic equation is 2. So this is some basics what we have to study, what we need to know before we start solving this case. Okay, so here I have described a very important topic related to quadratic equation. Now let me consider the equation y is equals to ax square plus bx plus c. Now if the value of a is greater than 0, what happens? How the graph looks? And if the value of a is less than 0, okay, what do you mean by greater than 0? Greater than 0 is nothing but it lies in the positive side. Less than 0, it's nothing but it lies in the negative side. As you can see, if the value of a is greater than 0, it lies in this direction. If the value of a is less than 0, then it lies in the negative direction. Okay, now as I'm going to show you the simplest graph, okay, as you can see here, let me draw a one section of the graph. As you can see, if the parabolic curve, if it is in this way, just a minute. Okay, so this is the curve. As you can see, this is my x-axis and this is my y-axis. The plane is cutting from this end to this end. It means it is moving in the upward direction. Okay, the graph is moving in the upward direction. This is very important, you should know. The curve is moving towards the upward direction. Now as you can see here, very simple, this curve, can you see this curve? Yes, this parabola curve where it cuts the x-axis, the parabola curve where it cuts the x-axis, it is cutting the x-axis at two distinct points, right? Yes, so this we call it as x-intercept. This we call it as x-intercept. The curve, the graph where it cuts the x-axis, that we call as x-intercept. Similarly, where it cuts the y-axis, we call that as y-intercept. Very simple. Is this clear? The graph where it cuts the x-axis, that is x-intercept. Where it cuts the y-axis, then it is y-intercept. Now we are going to draw the symmetry of this. As you can see, the mid of this, can you see this? So here, so this is the mirror symmetrical. We are just doing the mirror of this. Can you see this? This half side and this half side. We are doing the mirror symmetrical. Then this axis is known as axis of symmetry. This we call it as axis of symmetry. Okay. As you can see here, the graph changes its direction. As you can see, now the graph where it changed the direction, that we call it as turning point. Now we call that as turning point. Now you can see here, this is the point. Can you see here? This is the point which we call that as turning point. Okay. So what is turning point? The graph changes its direction. The graph where it changes its direction, that we call it as turning point. Remember, so here in this case the turning point is minimum. Okay, here in this case, if the graph is moving towards upward direction, then we call that as the turning point is minimum. Here if we get a curve in this way, turning point is minimum. And also you should know the key point, if we get a curve at the lowest point. Okay, if the turning point is at the lowest point, then we call the turning point is minimum. Very important information while you are solving your problems. If the turning point, we have to call that as minimum or maximum, how to identify? If we get the turning point at the lowest point, then we call that as turning point is minimum. Now we have solved the graph when a is greater than 0. I hope you have understood. Okay, if a is greater than 0, then how to identify x-intercept, y-intercept, and what we call the axis of symmetry, and which is the turning point. And we have also identified the major important thing in this case, how to find the turning point minimum or maximum. Now let me solve the next case. Okay, as you can see, the next case is if a is less than 0. If a is less than 0, let me take a plane. This is our x-axis and this is our y-axis. Now as you can see here, the graph, the parabola graph is leaning towards the downward direction. Okay, that it was upward direction, but in this case it is downward direction. It's moving in the downward direction. Now can you identify which is the x-intercept? Yes, of course, this is our x-intercept. X-intercept where it cuts the y-axis. This is our y-intercept. Y-intercept, and this is nothing but the axis of symmetry, the mirror of this graph. The mirror of this graph is axis of symmetry, and this is nothing but the turning point. So this is the turning point. Okay, the graph where it changes its direction in the upward case, that is the turning point. And here you should know the turning point. In this case, the turning point is maximum. In this case, what is the turning point? It is maximum. Why? Because we are getting the turning point at the highest point. We are getting the turning point at the highest point. That's what we call that as turning point is maximum. Turning point is maximum. Okay, please make a note of this point. One important note, that is x-intercept. Please make a note of this point. X-intercept lie on x-axis. Similarly, y-intercept lie on y-axis. Okay, and then line of symmetry is through the line of symmetry, that is axis of symmetry. Line of symmetry is through the x coordinate, of the turning point. X coordinate of the turning point. I hope the concept is clear for you all, right? Yeah. Now let me define what is one important thing now. Just a minute. Yeah, now take down this point. One more important note you need to remember now. What is that important note in this case? What we have observed, that is a parabola is the graph of a quadratic relationship. Okay, a parabola is the graph of a quadratic relationship. Next, the basic parabola has the equation y is equals to x square. Next, the vertex, that's nothing but the turning point. The vertex, that's nothing but the turning point is, let me assume a parabola. This is my parabola. Okay, so this is my x axis and this is my y axis. Now as per this graph, as you can see, the parabolic curve, the vertex turning point, in this case what is the turning point? As you can see here, the turning point is this point. Okay, where the graph is changes its direction. So in this case, the vertex, the turning point is 0, 0. Okay, this is the way you have to identify the turning point. Okay, now it is minimum or maximum? Yes, of course, it is a minimum turning point. Correct? It is a minimum turning point. Now what is the axis of symmetry? As you can see here, this is our axis of symmetry. According to this graph, as per this graph, this line, can you see the line which I am shading? Yes. So this is the line, is the axis of symmetry. So here in this case, axis of symmetry is x is equals to 0. Then what is x-intercept? In this case, the x-intercept is 0, right? And what is the y-intercept? The y-intercept is also 0. So we have drawn the basic parabola y is equals to x square. So this is the curve of y equals x square. If the parabola curve, if y equals x square, then remember the turning point is 0, 0. The turning point will be 0, 0, and it will get a minimum turning point. the axis of symmetry will be 0 and x-intercept is 0, and also the y-intercept is also will be 0. Okay, good. Now let me see the important fact. Okay, so what do you mean by axis of symmetry? Can you define that? Let me see. Very easy, very simple. Here the parabolas are symmetric. Okay, the parabolas are symmetric. What do you mean by that? As you can see, so this is my parabola. As you can see, this distance from here to here and from here to here, the distance will also remains same. It is the offset. Okay, this side offset is this side. That is what we call as symmetry. Okay, the parabolas are symmetric with respect to a line. With respect to a line. So the line is called the axis of symmetry. The axis of symmetry, and it is found by finding the x coordinate. By finding the x coordinate of the vertex. Okay, in case if we have to find the axis of symmetry, in case if you want to find the axis of symmetry, that is equals to x, we have the formula that is minus b by 2a, that is equals to h. Okay, so this is the formula which we use to find the axis of symmetry. Okay, it is represented by h. So the axis of symmetry equals x equals minus b by 2a, that is equals to h. Okay, so one important note in this case, you should know about this point. Okay, important note, what it is, that is axis of symmetry will change only, the axis of symmetry will change only when you shift the graph towards left or right. Okay, so the axis, so this is my plane. Okay, if your graph is like this, then which is the axis of symmetry? The axis of symmetry is this. If your graph is in this direction, this is the axis of symmetry. If our graph is in this direction, this is our axis of symmetry. As you can see here, if you are moving towards left or right, the axis of symmetry will change. Only in this case, the axis of symmetry will change. Okay, so let me solve one small example how to find the axis of symmetry. It will be very most important thing for you. Let me take case 1. If f of x is equals to x minus 4 whole square minus 4, then what is the axis of symmetry? Very simple. The axis of symmetry, that is x is equals to h, that is equals to 4. So the value of x is 4. Okay, so as you can see in this 4, this is my axis of symmetry. Now let me solve case B. How to find if f of x equals x square plus 5. Okay, then what is the axis of symmetry? The axis of symmetry x is equals to, in case if you have not understood this case, if you want you can use the formula also. As you can see in this case, option A, x minus 4 whole square minus 4. First you can change this into its standard form, a minus b whole square, a square minus 2 into a into b plus b square minus 4. Then x square minus 4 2 is 8x plus 4 square is 16 minus 4. x square minus 8x, 16 minus 4 is 12. In this case, we can see the value of a is 1, b is negative 8 and c is positive 12. We know that if you want to find the axis of symmetry, we have the formula x equals minus b by 2a, that is minus b value is minus 8 by 2 into the value of a is 1. Minus into minus is plus, 8 by 2 ones are 2, 2 ones are 2 fours are, so that is nothing but 4. This is the answer is 4. Okay, so you can solve in this way. Same way x square plus 5, let me solve this case. The formula is minus b by 2a. Okay, so x square second degree, first degree is not there, so we can assume that as 0x plus 5 because we have to change into its standard form. Okay, second degree, first degree, it should be in the form of ax square plus bx plus c equals 0. In this case, what is the value of a is 1, b is 0, the value of c is plus 5, right? Yeah. Now negative, the value of b is 0 by 2 into a is 1, minus 0, 0 by anything is 0 itself. So x is equals to h is equals to 0. Okay, this is the axis of symmetry. I hope you are understanding these cases, right? How to find the axis of symmetry? Good. And one more case if you want, I will solve. Similarly, you can solve n number of axis of symmetry of any of the equations. Done? Good. Now you can solve this case. F of x equals minus of x plus 1 whole square plus 4. Done? So what is the axis of symmetry of this equation? Let me see. It is not there in the standard form. First, let me convert that into its standard form. Okay, minus x plus 1 whole square plus 4 minus, let me take in the bracket, a plus b whole square, a square plus 2 into a into b plus b square. It is in this form, x plus 1 whole square. Then we have plus 4. Before this, let me close the bracket. Okay, so this is my x plus 1 whole square. What it is? This is my x plus, I have just expanded this x plus 1 whole square. Done? Good. Now, negative, minus into plus is minus x square, minus into plus is minus, 2 into x into 1 is 2x, minus into plus is minus, 1 square is 1, then this is the plus 4. Okay, so now we can see minus x square minus 2x, 4 minus 1 is plus 3, but the standard form is ax square plus bx plus c, right? But what we can do here, we can take, let me assume this is equals to 0, we can take negative as common factor, then it becomes x square. Okay, if you want, you can take in this form also. The value of a is minus 1. Done. Then what is the value of b? The value of b is minus 2. The value of c is plus 3. We know that to find the axis of symmetry, we have the formula axis of symmetry is equals to x is equals to minus b by 2a, that is minus value of b is minus 2. Okay, value of b is minus 2 by 2 into value of a is minus 1, then minus into minus is plus 2 by just a minute, actually what should be the standard form? The standard form is positive ax square plus bx plus c, right? Yeah, good. Then minus 2. Okay, 2 by plus into minus is minus, 2 ones are 2, 2 ones are 2 ones are, so it's nothing but minus 1. So here the axis of symmetry is x equals minus 1. I hope the concepts are clear for you all, right? Very good, students. So if you have to show in the graph, it will be in this shape. Where is the axis of symmetry? In case if my curve example I am just taking, let me take an example in such a way. Okay, so this is my axis of symmetry. as you can see here, this is x equals minus 1. This will be my axis of symmetry. Actually, you get a parabola curve, something like this. Okay, good. I hope you all have understood how to find the axis of symmetry, right? And we have discussed all the key points about axis of symmetry, x-intercept, y-intercept, and how to find the turning point. And also we have simple transformations of the graph of y equals x square. Okay, if you want, you can just go through this point, go through this step. This makes a important sense, so that you will be understanding all the key points, okay, related to parabola. Okay, let me take the title, simple transformation, simple transformations of the graph, simple transformations of the graph of y equals x square, which includes the first topic is dilation. Okay, so what it is dilation means, let me see how it will looks the graph. So this is my x plane, okay, and this is my y plane. Okay, now as you can see, this is the curve, this is my curve, which is y is equals to x square. This is my curve, y is equals to x square. Now you can see we are getting one more graph. Let me say this is y is equals to 2x square. This is y is equals to 2x square. Let me draw one more curve, one more graph. As you can see here, this is my graph. So this is nothing but y is equals to half x square. As you can see the changes in this, right? So this is nothing but which is called as dilation. Similarly, let me see the next topic, reflection. Okay, what the meaning of reflection? Let me see here. Very easy and very simple to understand. Let me draw a plane. Okay, let us draw a plane x, and this is y. Okay, good. Now I am drawing a parabola graph of y is equals to x square. Assume this is my y is equals to x square. And how about the reflections? As you can see here, very easy and very simple. Yeah, just a minute. Good. So this is a parabola curve. Let me say y is equals to, let us say y is equals to negative x square. Okay, and then you can see here, just I am taking an example. Okay, so this is my y is equals to negative 2x square. So this is the reflection. Okay, then the last topic is translation. The last topic is translation. Okay, my dear students, still if you have not subscribed to my YouTube channel, Shah Sir Classes, do subscribe it and click the bell icon and select the notification all, so that you can find the instant notifications and updates from my end time to time. Okay, good. Now this is my x axis and this is my y axis. Now you can see the difference between dilation, reflection and translation. Now I am drawing a parabola graph of y is equals to x square. Okay, this is my y is equals to x square. So this is my parabola curve. I'm taking a rough figure. Okay, it's not so much actual figure. Okay, now I'm just showing. Okay, now you can see a parabola curve of y is equals to x square. Okay, and then as you can see here, we have one more parabola curve. It's here. This is y is equals to x square plus 2. Y is equals to x square plus 2. And then as you can see, we have one more parabola curve. We have one more parabola curve, which is this. This is y is equals to x minus 2 whole square. Okay, and then we have one more parabola curve. Let me see this. Okay, so this is y is equals to x plus 3 whole square. As you can find the axis of symmetry, the turning point, and x-intercept, y-intercept in these planes, right? Good. And ultimately, let me take one more deflection, how it looks. Okay, let me take an example of this. Okay, so this is nothing but y is equals to x square minus 3. Okay, so we have compared the different graphs with the basic rule of parabola, y equals x square. I hope these concepts are clear for you all. Wish you all the best of luck. If you have liked this class, do not forget to click the like button and share this video as much as possible with your all friends and also along with your classmates. Thank you. Take care. Bye bye. In our next class, we are going to explain you the turning point, the different methods which we are using to find the turning point. Thank you. Take care. Comment below how was this class and what video you want to make me next. Take care. Bye bye.